Now next point is about multiples and submultiple values of trigonometric functions. So we will do like this. If you are given x, then we can find here sine 2x, sine 3x, and so on. These are called multiples. And if you are given x, then we can find like sine x by 2, 10x by 2, even sin x by 4, and so on. These are called submultiple values of this trigonometric functions, remember, of trigonometric functions here. So we want to discuss such formulas now. Right. So far we have discussed, addition formulas, then vector formulas. Now there is a last point here in this trigonometric functions. So first we go for here, first one, that is sine 2x, formula for sine 2x in fact. So here sine 2x you can write as sine x plus x. 2x we can write x plus x. Now this is like x, this is like y, so I'm using addition formula. So sine x cos y, y is also x, plus cos x into sine y, y is also x here. This is like x, this is like x, and this is like y. So sine x cos y plus cos x sine y. Now this is same as this, you can see, so this will be double, so twice sine x into cos x. So this is the formula for sine 2x, first formula in this direction. What is the formula for sine 2x? 2 and half of this angle, remember. What's the half of this? That's x. So I can write like this. If I want to write the formula for sine 4x, I can write like this. Sine 4x will be 2 is there, and then half of this angle. What's the half of this? That is 2x. So sine 2x into cosine 2x. This way we can use. The fundamental formula is this, remember. Sine 2x equals to 2 sine x cos x. 2 is always there, and you have half of this angle. This x is half of 2x. I can write like this also. Sin x equals to, if I write, 2 is already there, and then half of this angle, that is twice sine x by 2 into cosine x by 2. This is the formula. One more. These are mainly based on this only, remember. I can write like this also. Suppose I have sine 8 theta. So I can write twice sine half of 8, which is 4 theta, into cosine of 4 theta. This way we can use. Right? So this is one formula about sine 2x. Now same way we go to formula for cos 2x now. Cosine 2x. Cos 2x. This proof is not important for you, remember. This is just I've shown. The important one is formula, remember. Okay, now we write the formula for cos 2x. So I can rewrite like this here. Cosine 2x I can write as cos of x plus x. 2x is x plus x. Now we use addition formula here. So cos x into cos y, y is x, minus sin x into sin y, y is also x, remember here. Which formula I've used? Just I'll write here this one, cos x plus y. What is cos x plus y? Addition formula, cos x into cos y minus sin x into sin y. This is what I've used. But here in place of y you have, so we have this. Now what is this? This is cos square. What is this? Sin square. So this is the first important formula for cos 2x. So what is cos 2x? Cos 2x is nothing but here cos square x minus sin square x. Cos square x minus sin square x. If you put plus, it becomes 1. Remember, there's a difference. What is cos square x plus sin square x? It is 1. Remember, this is 1. If I put plus sign here, it is 1. But if I put minus sign, it is cos 2x. Cos 2x equals to cos square x minus sin square x. So this is formula for cos 2x, and this is the formula for sin 2x. Sin 2x is given by this, remember. So now we have cos 2x. What is cosine 2x? We already shown that it is cos square x minus sin square x. Now I'll rewrite cos square in terms of sin square. You know cos square x you can write as 1 minus sin square x. This you know, this is fundamental formula. So I place here 1 minus sin square, and minus sin square is already there. So this become 1 minus 2 sin square x. So this is the second formula for cos 2x. Remember, what is cos 2x? It is nothing but the 1 minus 2 sin square x. Again, I'll start with this. Again, I'll start with cos 2x equals to cos square x minus, in place of this sin square, I'll write 1 minus cos square x. So I'm converting in form of cos. So this would be, if I open the bracket, this is double. Cos square plus cos square. Twice cos square x minus 1. So this is the second formula for cos 2x. So in short, we have this 3 formula here. Therefore, cos 2x has this 3 formula. One is cos square x minus sin square x. Second one is 1 minus 2 sin square x. And the third one is 2 cos square x minus 1. You need to remember. These are the 3 formula for cos 2x. Cos 2x equals to cos square minus sin square, 1 minus 2 sin square, and 2 cos square minus 1. What is important observation here? Angle will be half on right hand side. You see what's the half of 2x? It is x, 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 x. That's important observation, remember. For example, here you can do like this. I'm just showing. If I have cosine x, I can write here cos square x by 2 minus sin square x by 2. You see half of the angle. Half of this is x by 2. We can write 1 minus 2 sin square x by 2. You can write 2 cos square x by 2 minus 1. Right? I can write one more if I show here. Suppose I have, let's write, suppose I have cosine 4 theta. So I can write one as cos square half of this, which is 2 theta, minus sin square 2 theta. I'm just showing so you can understand how to use in the sums. Equals to 1 minus 2 half of 4, that is 2 sin square 4 theta, 2 theta here, half of 4, and 2 cos square half of 4 theta, which is 2 theta minus 1. So this way we can use the formula for cos 2x. Okay. Now next, that is formulas for sin 3x, cos 3x, and let me write tan 3x. We write this formula for sin 3x, cos 3x, and tan 3x. This can be proved like a standard result. I'm not going to prove this. I'll just write the formula. Sin 3x equals to, I'll write here without proof, 3 sin x minus 4 sin cube x. This is a direct formula for sin 3x. Right. If you are interested, you can try it like this. Sin 3x, you can write sin x plus 2x. Now use addition formula here. and try to simplify. This is just the brief idea I'm giving you. If you are interested, why this formula, I'm just telling you. But that proof is not important. All these proofs you will find in the textbook if you are interested. The important one is this: sine 3x is 3 sine x minus 4 sine cube x. And the second one here, cos 3x equals to cosine 3x equals to, interchange these two terms, 4 cos cube x minus 3 cos x. Just you have interchanged the terms, that way you can remember. Right? What we did, we have interchanged the terms, remember. What I did, I have just interchanged the terms here. Sine 3x is 3 sine x minus 4 sine cube. Cos 3x is equal to 4 cos cube x minus 3 cos x. How will prove it? You can start with cos 3x equals to, here cosine, you can write x plus 2x. Right? Now use the addition formula. You can write cos x into cos 2x minus sin x into sin 2x. Now everything you want in terms of which function? Cos function. So write the formula for cos 2x. Here cos x equals to, what is cos 2x? You know the formula, this one. 2 cos square x minus 1. So you can write this, 2 cos square x minus 1. Minus this sin x as it is. What about sin 2x? You can write 2 sin x into cos x. Right? So this is, you just simplify, you will get this formula. I'm just showing you. That proof is not important for you, but just for your information I'm showing you. Okay. Now third one here, that is formula for tan 3x. Tan 3x. Sin 3x is purely in terms of sine, cos 3x is purely in terms of cos, and tan 3x it's purely in terms of tan, which is given by 3 tan x minus tan cube x upon 1 minus 3 tan square. Right? Not difficult to remember, but you have to remember. Tan 3x is 3 tan x minus tan cube upon 1 minus 3 tan square. 33 upon 32. At both the places you have minus sign. Tan 3x is 3 tan x minus tan cube upon 1 minus 3 tan x. 33 upon 32. 33 upon 32. That way you can remember. Right? This is the formula for tan 3x. How will give you the proof? If you are interested, you can write tan 3x equals to tan x plus 2x. And now use the formula. So you can use, if you remember, tan x plus tan y. Tan x plus tan y upon 1 minus tan x into tan y, and then further you can simplify. Just giving the idea, remember, not the entire solution. This way it can be proved, remember the formula. So 3 more formula. First one, sin 3x, 3 sin x minus 4 sin cube, cos 3x, 4 cos cube minus 3 cos x. Interchange the terms. You see, you have interchanged the terms. And tan 3x is 33 upon 32. Okay. Now the next one, that is formula for, next is formula for here. Formula for sin 2x, cos 2x, and tan 2x. This one in terms of tan function. In terms of tan function. Tan function. We did formula for sin 2x. Now here, the first one, sin 2x, which I can write 2 sin x into cos x, you know. You can imagine upon 1. So in place of 1, I can write cos square plus sin square. Cos square x plus sin square x. Now I want to reduce in terms of tan. So what I'll do, I'll divide numerator and denominator. Numerator and denominator by, I want tan, so cos square. Dividing both numerator and denominator by cos square. Why? Because I want tan function. So if I divide by cos square, 1 cos will get cancelled, sine upon cos, which is 2 tan x. Cos square will get cancelled. So here 1 sine square plus upon cos square, which is tan square. So we have sine 2x equals to this. So this is the formula for sine 2x. 2 tan x upon 1 plus tan square, half angle. You see, you had 2x, now it is x. Same way, this is not important, just I'm showing you for your information. Cos 2x. You can write cos square x minus sine square x. You know now this, we already done. You can imagine 1 here. Instead of 1, you write cos square plus sine square. Then divide numerator and denominator by cos square here. Same what I did here. So you will get 1 minus tan square upon 1 plus tan square. This is the formula of cos 2x. Remember, right hand side you have half angle. Sin 2x is 2 tan x upon 1 plus tan square. Cos 2x is 1 minus tan square upon 1 plus tan square. And finally, tan 2x, which is just the ratio of these two. Tan 2x, you can write sin 2x upon cos 2x. Now put the value of sin 2x here. What is sin 2x? That is 2 tan x upon this. What's cos 2x? 1 minus this upon this. So that plus term will get cancelled. Only you are left with this one. 2 tan x upon 1 minus tan square. Right. So therefore, finally, tan 2x equals to 2 tan x upon 1 minus tan square. This is the formula. Here your minus, remember. I repeat, 2t upon 1 plus t square. This way you can remember. 2t upon 1 plus t square. You can remember this way. 2t upon 1 plus t square. T stands for tan. This you can remember 1 minus t square upon 1 plus t square. And this you can remember here 2t upon 1 minus t square. Right? How do you remember this? Sin 2x is 2t upon 1 plus t square. 1 minus t square upon 1 plus t square and 2t upon 1 minus t square. This is just the ratio of these two. You can see that these two will get cancelled. 2t upon 1 minus t square. So these are the formula for sine, cos and tan in terms of tan function here. Like if I see this way here, for example, if I use this, suppose I want to write sin x in terms of tan. So 2 tan half angle, remember, x by 2 upon 1 plus tan square x by 2, half angle. Right? Here you have half angle. This was 2x, this is x, remember. How do I write cosine x? 1 minus tan square x by 2 upon 1 plus tan square x by 2. How do I write tan x? That is 2 tan x by 2 upon 1 minus tan square x by 2. This way we can use the formula. So now one more here. Formulas for sine square and cos square. Even you can write tan square also. Formulas for sine square, cos square and tan square in terms of cosine function, in terms of cos functions. Cos function, remember, in terms of cos function. These are called sometimes double angle formula. You will see how I'm writing. You already studied. What I'll do, I'll just write from one of the earlier formula. You just recall this. You have this, if you remember. Now make the sine square as subject of expression here. What I'll get if I put the sine square as a subject of the expression? Interchange these two. So sine square x become here 1, this will go that side. So minus cos 2x and into 2 will be down, so by 2. This is the formula. So that's what I want to write. Right? So I'm writing that. So sine square x equals to 1 minus cosine 2x, you see angle is double, the whole by 2. Right? Using this, just I'm writing here using cos 2x equals to 1 minus 2 sine square x, using this. Make the sine square as a subject of the expression, you will get this. Make the sine square as a subject of the expression, you will get this. So this is very, very important formula, remember. Okay. So one is this. Here, second one, same way, cos squared x equals to 1 plus cos 2x the whole by 2. From where this? Because of this. You recall the second formula for cos 2x, it is 2 cos square x minus 1, if you remember. Make the cos square x as the subject of expression here. So plus 1 the whole by 2. This is the second formula, remember. And how do we write tan square, which is just the ratio of these two? Tan square x equals to ratio of the sine square upon cos square. So 1 minus cos 2x upon 1 plus cos 2x. Okay, so we have this now. This is the third important formula here. This is just the ratio of these two. These proofs are not important here, remember. I'm just giving you brief idea how we are getting this. These are called double angle formula. You see angle become double here. Like this here, if I have, for example, see I can use like this here. If I have sine square x by 2, then angle will be double. 1 minus cosine x the whole by 2. What is cos square x by 2? Angle will be double. So it will be 1 plus cosine x the whole by 2. What is tan square x by 2? That is 1 minus cosine x upon 1 plus cosine x. These are the three expressions in terms of cos function. This angle is double than this, you can see here. Here it is x by 2, here it becomes x. How will use this? That's very important question. For example, here, suppose I want to get find. This is the question. Find. Let's write sine pi by 8. This is the question. Pi by 8, or even cosine pi by 8, or even tan pi by 8. Now what is pi by 8? Pi by 8 is half of pi by 4. So this is sine half of 45, that is 22.5 degree. This is cosine 22.5 degree. This is tan 22.5 in terms of degree. Right? We want to find this value. So what we do? We don't have pi by 8, but we know double of pi by 8. What's the double of pi by 8? Double of pi by 8 is pi by 4. Pi by 4 values you know. So I'll use this double angle formulas. So I'll start with, in each formula you have square. So I'll start with sine squared pi by 8. So it will be 1 minus cosine double of pi by 8, which is pi by 4 the whole by 2. Got it? This way. Now cos pi by 4, you know what is cos pi by 4? 1 by root 2 the whole by 2. So this will be root 2, if I take LCM, minus 1 upon 2 root 2. You can just rationalize this root 2. So multiplying and dividing by root 2. So what I'll get here? Root 2 gives you 2 minus root 2 upon root 2 and by 4. This is the value of sine square pi by 8. but you are interested for sine pi by 8, so you can take the square root. So what's sine pi by 8? It is root of 2 minus root 2 the whole by 4. Right? So if in case in sums, if you require this, you can do this much work and you can find it. Same way you can find here cos pi by 8. So cos pi by 8, the only difference is here we'll get the plus, 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 plus. So here what's the value of cos pi by 8? It is 2 plus root 2 the whole by 4. Right? 10 pi by 8. Next, suppose I want 10 pi by 8. So what I'll do here, I'll start with the formula of 10 squared pi by 8. So it is 1 minus double of this, which is cosine pi by 4. You must have realized I'm using this formula. I'm just using this formula, remember. Upon 1 plus cos pi by 4. Pi by 4, you know, it is 1 by root 2. 1 by root 2 and I'll take LCM. So root 2 minus 1 upon root 2 plus 1. Now normally, what I did, placing the value of this, which is 1 by root 2. And then I took the LCM. So root 2 minus 1, root 2 plus 1 and root 2 are cancelled. You must have realized. Now I'll take the conjugate. Normally we never keep irrational number here. So root 2 minus 1 upon root 2 minus 1. You know such things, rationalization. So what happens here? This is a plus b, a minus b. A plus b, a minus b, which is a square minus b square. So 2 minus 1. Root 2 whole square 2, 1 square 1. And this is root 2 minus 1 the whole square. This is 10 square pi by 8, remember. This is 1. So finally, what is 10 pi by 8? So 10 pi by 8 equals to this square and this square will get cancelled. So root 2 minus 1. So this way we can find some values here, remember. So now let's discuss some examples based on this vector formula. First question, prove that this equals to cot x. So we concentrate at angle x. You see it becomes half of 2x. So we start with LHS here in the solution. I'll start with left hand side here. LHS. What is LHS? That is sine 2x upon 1 minus cos 2x. Now what is sine 2x? You know the formula, 2 sine x into cos x. Now what about 1 minus cos 2x? If you remember the last double angle formula, 1 minus cos 2x, you can write 2 sine square x. 1 minus cos x, you can write 2 sine square x. So I can write here 2 sine square x. Just for your information, I'm writing the formula here. You know sine square x equals to 1 minus cosine 2x the whole by 2. So what is 1 minus cos 2x? 2 sine square x. So now you are through. 2 will get cancelled, 1 sine will get cancelled. So we are left with cosine upon sine x. And what is that? It is cot x, which is RHS, right hand side. That is right hand side. 1 sine will get cancelled, 2 will get cancelled, cos upon sine, which is cot x. Question number 2 here. Let me go for second question. You are given 10x by 2, cot x by 2, and you want to prove this second question. So for the second question, let me start with LHS here. What is left hand side here? 10x by 2 plus cosine cot x by 2. So the first step is obviously we reduce it into sine cos. So sine x by 2 upon cosine x by 2 plus cos x by 2 upon sine x by 2. And then next step is obviously cross multiplication. This with this, this with this. So I'm doing that. So this is equals to here, the next step, this is equals to sine square x by 2 plus cos square x by 2. So you must have realized numerator upon you have sine x by 2 into cos x by 2. This is just LCM. What is numerator? You know that this is 1. Sine square plus cos square is always 1. Now if you recall the first formula here, 2 sine x by 2 cos x by 2. So you require 2 here. Just recall this formula. If you just have a look on this, not this one, sorry, this formula. See this, you require 2 here. So what I'll do, I'll multiply and divide with 2. So I'll write here into 2 upon 2 sine x by 2 into cos x by 2. So this will be 2 upon, now this is sine x, and if I take in the numerator, this is cosec x. So that is your RHS, and therefore you are through. Okay, now next question number 3 here, third question. Third question is cos x upon 1 plus sin x. This is a really nice question. You look at it RHS. What is right hand side here? That is in terms of x by 2. Remember, this pi by 4 will come automatically. That's not important as x by 2. That means formula for cos x in terms of x by 2 and this one in terms of x by 2. So I'm using this. You see, this is equals to, here I'll write cos square x by 2 minus sin square x by 2. You know this formula for cos, upon 1 as it is, instead of this as I did right now here, twice sin x by 2 into cos x by 2. Now in Trigo, this is very common expression, you will see later on also. Instead of 1, I can write sin square x by 2 plus cos square x by 2. Why I did this? Plus this one as it is. This one I am copying. What about numerator? That is as it is. Numerator as it is. What's the numerator? Cos square x by 2 minus sin square x by 2. What I did here, just in place of 1, I wrote this. You know that this is 1. Why this? I'll answer the question. You will also realize, and this is very common in Trigo, you will see. Now this is a perfect square. A square plus b square plus 2ab. So this is nothing but the cos x by 2 plus sin x by 2 the whole square. Fine. Now this is a square minus b square. This is a plus b the whole square. It has two factors, minus and plus. Plus will get cancelled. So we are just left with this. You must realize why like this. I repeat, it's like this. See, numerator has two factors, a minus b and a plus b. Upon, this is like a plus b the whole square. So plus factor will get cancelled, so you are left with this. A minus b means cos minus sine, a plus b means cos plus sine. Now, one way is you can just leave this as it is, call this as equation 1. Go to RHS. Now I'm doing RHS, remember. So let's go to right hand side. I'm doing right hand side now here. So what is RHS? That is 10 pi by 4 minus x by 2. Now this is which formula? Addition formula. 10x minus 10y. 10x means 10 pi by 4, which is 1, minus 10y, which is 10x by y, upon 1 plus 10x means 10 pi by 4, which is 1 into 10x by 2. Now you must have realized, instead of 10 you write sine by cos and take cos as LCM. So cos x minus sin x by 2 upon Here sin x upon cos x, take cos as the LCM, and cos you can cancel from the numerator and denominator. You see, this is 2. Now notice 1 and 2. This is 1, this is 2. So what's the conclusion from 1 and 2? LHS equals to RHS from 1 and 2. Root. This is a way of doing this question. Or you can do directly this, then you can write this, and then you can write this. So you'll get LHS to RHS. Nice question. Now I'll take 2-3 questions from 3.3 your textbook. 23 question number. Prove that tan 4x equals to this. You see here your 4x, everything is in form of tan x. So in the solution, I'll start with LHS. Left hand side. What is left hand side? Tan 4x. Now first, there are 2 ways to do this. You can write here 2x plus 2x, or you can use x plus 3x, whichever way you do it. I'll use this here. Tan 2x equals to 2 tan x upon 1 minus tan square. I'll use this. 2 tan x equals to 2t upon 1 minus t square. Remember, you had 2x, here it is x. So here what I'll get, 2 tan half of this, which is 2x upon 1 minus tan square 2x. Which formula I've used? You know formula for sine, cos and tan in terms of tan function. You know this formula, right? I've used this one, remember here. So from tan 4x to 2x, I want in form of x. So I'll use the same formula here. 2 as it is. In place of tan 2x, I'll write the same formula. So 2 tan x upon 1 minus tan square. Your 1 minus 2 tan x upon 1 minus tan square, the whole square. Square is there, remember. So I've used this formula twice. So now sum is almost over. You simplify. That's the question. So what is LCM here? 1 minus tan squared whole square is LCM, remember. So this will be 1 minus tan squared the whole square minus this will be 4 tan squared. Now here whole square LCM, here just 1 minus tan squared. So 2 into 2 tan x. This square and this is single one. So here you are left with 1 minus tan squared. And simplify. This is your answer. I repeat. Here you see 1 minus tan square whole square. It will be multiplied with this. So here LCM is whole square. Here just 1 minus tan square. So you have extra 1 minus tan square here. And then just you do this numerator you obtain. You see numerator you've done. Now you just expand this. So I think you'll get almost RHS. Do that step. I leave it for you. This is one question. One more question. 24 I would like to do. They prove that cosine 4x equals to 1 minus 8 sine square into cos square. Okay. So I'll start with here again LHS. Let me start with left hand side. Cos 4x. Now here I want x only. So first I'll use here, I need 1 also. So there are 3 formula for cos 2x if you remember. One is cos square minus sine square, if you remember. Then 1 minus 2 sine square. And if you remember 2 cos square x minus 1. These are the 3 formula for cos 2x. Cos square minus sine square, 1 minus 2 sine square, 2 cos square x minus 1. I need 1. So I'll use this 1 minus 2. Now half of this angle, that is 2 sine square 2x, remember. Don't forget half of this 4x, which is 2x. Which formula I've used? This one. This is the formula for cos 2x. Why I've used this? Because I want 1, remember. I have right hand side in my mind, remember. Now you are through. You don't want 2x, you need x. So 2 as it is. Now write the formula for sine 2x. Write the formula for sine 2x. What is that? 2 sine x into cos x the whole square. So finally, this is 1 minus 2 square is 4 into 2, 8. This is sine square x into cos square x. This is your RHS, and therefore you are through. LHS equals to RHS. One more question from that exercise. Question number 25. Prove that cos 2x equals to this much. Everything is in form of cos. Don't worry about raised to 6, raised to 4, raised to 2. That will come automatically. What is the important observation? It's about right hand side is about cos function. So in the solution, I'll start with LHS. Solution, that is left hand side, which is cosine 6x. So I'll rewrite like this. This is cosine 2 into 3x. Fine. Now this looks like x, remember. So it becomes a formula for cos 2x. You imagine this bracket like x. So this looks like cos 2x. Now formula of cos 2x in terms of cos function, which is this formula if you remember. Cos alpha equals to 2 cos squared alpha minus 1, this formula. So I'm using this. Twice cos squared, here alpha means 3x, remember. X minus 1. I hope this is clear to you. You are clear with this. What I did, 6x I wrote 2 into 3x. Right? All these things you will learn by practice, not a big task, remember, don't worry. Now you imagine this 3x like x, so this looks like 2x. So a question comes to formula for cos 2x. Now cos 2x has 3 formulas if you remember, 1, 2 and 3. So which one you will use? The one that involves purely cos function. So that is this formula. So 2 as it is. Now you don't want cos 3x. So what I'll do? I'll use the formula for cos 3x now. What is the formula for cos 3x? 4 cos cube x minus 3 cos x. The whole square is already there and minus 1 is also there. Right? Formula for cos 3x. 4 cos cube minus 3 cos x, the whole square minus 1. Now almost you are through. Just expand this. If I expand this, this will be a minus b the whole square. So 16 into cos raised to 6 minus 4 3 the 12 into 2. 24, this into this, cube and this, raised to 4, this into this, plus 9 cos square x minus 1, remember. So this would be 32 into cos raised to 6 minus 48 into cosine raised to 4 plus 9 into 2, that is 18 into cos square x minus 1. This is answer to the question. This is RHS and therefore proved.